In problem 14, we have three sets of conjugate fractures, and we are going to plot them on a Stereonet and find out the trend and plunge of principal stress directions, which are sigma 1, sigma 2, and sigma 3. And based on the definition from previous problem, you might remember that the intersection of two conjugate fractures are always sigma 2. The intersection of the acute angle is sigma 1, and the intersection of the obtuse angle is sigma 3. So here I'm just showing, one example, quickly, just as a sketch how they should look like on Stereonet. Then we can move on to Stereonet and investigate in details. So first of all, we need to plot, let's say we have two fractures. You need to plot them. All right, let's say I'm just plotting, okay, just roughly. They might look like something like that. All right, so if you have these two fractures, the intersection, it's gonna be sigma 2. You can find out the trend and plunge. That's very easy, right? So what you're gonna do is finding sigma 1 and sigma 3. If you remember, I mentioned that these three principal stress directions are perpendicular to each other. Let's say here we have three axes, all right? Let's say this is sigma 1, let's say this is sigma 2, and this is sigma 3. And as you notice, all right, you see sigma 1, let's assume the sigma 2 and sigma 3 are creating a surface, right? And sigma 1, it's going to be the pole of the plane that is crossing sigma 2 and sigma 3, right? So in another word, we can say if we have a plane, let's call it sigma 2, sigma 3 plane, sigma 1, it's going to be the pole of that plane, right? Or we can go with the plane of sigma 1 and sigma 2, right? Let's say this is a plane that is going through these two axes, sigma 1 and sigma 2. In that case, sigma 3 is going to be the pole of that, right? And same thing for the other one, right? If we have a plane of sigma 1 and sigma 3, right? If this is a plane that goes through these two axes, then sigma 2, it's going to be the pole of that plane, right? So if we turn that back to Stereonet, we have the pole, right? Which means we have this dot here, and what we can do, we can draw the profile plane of sigma 2, and that's going to be the plane of sigma 1 and sigma 3, or in another word, sigma 1 and sigma 3, it's going to be plotted along that plane, right? So what I'm going to do, I will go ahead and place, sigma 2 along the east-west line, and you can count 90 degrees from this point, and that's going to be the profile plane, right? Let's say I have done that step and I obtained this great circle, right? And that is the plane of sigma 1, sigma 3, all right? But we don't know yet where is the sigma 1 and sigma 3, right? So how we know this? We need to count the angle between these two fractures, right? So you need to count this angle along that dashed line, right? So if this angle is obtuse angle, then the intersection of this angle, it's going to be sigma 3. If it's acute angle, that's going to be sigma 1. What I'm going to do, I will count this angle, right? Let's say I'm going to place this dashed line on a great circle, and I'm going to count this angle, and that's about 120 degrees, right? Because this angle is larger than 90 degrees, it's going to be, obtuse angle, and the half of this, it's going to be 60, right? You divide this by 2, it's going to be 60 degrees. Then from here, doesn't matter, or from the other end, you count 60 degrees and you find the middle point, right? So because this is the obtuse angle, that's going to be sigma 3, right? And then we know sigma 1 is along this great circle or dash line. Then you can count 90 degrees along this line, right? It doesn't matter in which direction you are counting, because you're going to end up to the same location. Let's say I'm going to count 90 degrees, and somewhere here I'm going to end up to sigma 1. All right, so we are going to look at to the details on the Stereonet. In problem 14, 3 sets of the conjugates are given. I'm going to plot the part A. The numbers that I have, it's 45 for the strike. So let's count that one: 10, 20, 30, 40, 45. And the dip is 64. These data, it's given the right hand rule. So again, if this is the strike, so this is the strike, so let's put that way. So this is the strike and it's dipping that way, right? My right hand, the thumb shows the direction of the strike and the forefinger is towards the dip, all right? So if I count 90 degrees after strike, that's going to be the dip direction, right? So from here, what I can do, I will place this one along the sign along the north-south direction, and 90 degrees here, right, clockwise, and I'm gonna count the dip, which is 64. 10, 20, 30, 40, 50, 60. This is 64. All right, so next one is 290, 88. The strike is 290. So this is 270, 290 is here. The dip is 88, right hand rule, it's dipping towards northeast. So what I'm gonna do, I'm gonna place this sign along the north-south line, and I'm gonna count from the northeast direction, right? How many degrees? 88. So it is just close to 90, right? And this is the another plane. All right, so here I have the intersection, and we know the intersection of the two conjugates, it's gonna be sigma 2, right? This is sigma 2. We know that sigma 1, sigma 2, and sigma 3 are perpendicular to each other, right? These are they are orthogonal system. So you know that if I plot the profile plane of sigma 2, that's going to be a plane which the sigma 1 and sigma 3 should be on that plane, right? So let's plot the profile plane of sigma 2. So we place that one here. I'm gonna count 90 degrees and then trace the great circle. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, right? So I'm gonna put a dash line, and that's the plane that sigma 1 and sigma 3 is sitting on it. And based on the definition, we know the sigma 1 is bisecting the acute angle, right? So what we have here, we have these two planes. We can count this angle. If this angle is less than 90 degrees, then that's gonna be acute angle, right? And the intersection of this angle, that's gonna be sigma 1. If this angle is larger than 90 degrees, then that's the obtuse angle, and the intersection of that angle, it's gonna be sigma 3. So we don't need to move the vellum paper. We can count the angle right away. Here I have 3 degrees. Okay, 13, 23, 33, 43, 53, 63, and 68. Okay, this angle is 68. So if I divide it by 2, it's going to be 34. If I count 34 from one end, it doesn't matter which one, right? Because it's the central point. That's going to be my sigma 1. I have 3 degrees here, 13, 23, 33, and that's the 34, right? This is the central point of this angle, right? That's going to be sigma 1. Why? Because the sigma 1 actually is bisecting the acute angle. And we know sigma 3 is perpendicular to sigma 1, right? If I keep counting 90 degrees along this dashed line, that's going to be my sigma 3. So I have 9 degrees here, okay, 19, 29, 39, 49, 59, 69, 79, 89, and 90, and that's gonna be sigma 3. So we have sigma 1, sigma 2, and sigma 3. And we need to find the trend and the plunge of these sigma 1, sigma 2, sigma 3, right? Because these are the linear feature, right? These are the axes, right? So what I need to do is I need to make a sign for a line that goes through the center and my points. One here for sigma 2. For sigma 1, it's going to be here. And for sigma 3, it's going to be here. These 3 small lines showing the trend of sigmas, right? So for sigma 2, it's 90, 100, 103 slash. For sigma 1, let's say 180, 200, 220, 240, 250, 253. And this one is 350. Put the slash. All right, so I need to read the plunge. The plunge is 10, 20, 30, 40, 50, 60. This is 60. This is sigma 2. This one is 10, 20, 28. This is sigma 1. And the other one, it doesn't matter, you can place it along northeast line or west-east line. And this one, it's about 13 degrees. So 350 slash 13 is sigma 3. So we are done with part 1. Let's move on to part 2. So I'm going to take this one out. So 113, so that's gonna be 100, 110, 113, and the dip is 30. We know that's the right hand rule, so 90 degrees after strike. You can add up 90 degrees on the strike, and that's the dip direction, and then you count 30 degrees from there. So I place it this line on the north, and from the east-west line, from the eastern side, I count 30 degrees. So this is one of the conjugates. The second one is 310, 26. So here is 270, 280, 290, 300, 310. And it's 26, so it's dipping that way. 26. 10, 20, 26. So make sure that you are tracing the great circles, okay, carefully. All right, we have the intersection here. So what I'm gonna do, I can read the trend and plunge of that. We know this is sigma 2 and the trend is 100, 110, 119 and the plunge is 4 degrees. That's sigma 2, and sigma 1 and sigma 3 are in the profile plane, right? You place that one there, 4 degrees. So from the center I go 4 degrees. That's my sigma 1, sigma 3 plane. Right? Now we count the angle between these two planar feature or joints. You see that's going to be, obtuse angle, right? Let's count how many degrees we have. It's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 124. So 124 is going to be 62. 10, 20, 30, 40, 50, 60, and that's 62. So this is the center of this distance. So this is the obtuse angle. So the axis that's bisecting the obtuse angle, it's going to be sigma 3, and 90 degrees off from that, that's going to be sigma 1. So here we have the east-west line. This is just 2 degrees off. So from this side 2 degrees off, that's going to be sigma 1. All right, so let's place the trend for these two axes. This is for sigma 1 and that is for sigma 3. Okay, the trend for sigma 1 is 180, 190, 200, 208 slash, and as you see this angle is just 2 degrees, right? 0, 2. And this one here for sigma 3, here we have 360, right? 350, 340. This is 5, 335, and this is the plunge. So rather than counting this, right, you can count this and subtract by 90, whatever it's easier for you. 10, 20, 30, 40, 50, 60, 70, 80, 85. So this is 85. This is the trend and plunge of sigma 3. This is the trend and plunge of sigma 1, and this is for sigma 2. Let's move on to the third part. In these three different examples, you see different type of in these three different examples, we see different type of the angles and how we count, right? So the third one is 90, 90. So this is interesting. So the trend is 90, okay, and it's dipping 90. So here is 90, and this is the right hand rule, right? So that's going to be like that, right? It's dipping towards south. How many degrees? 90 degrees. So that's going to be, right, that's going to be exactly, you can count 90 from here, and you're going to end up to the to straight line from north to south. All right, so that's one. And the second one is 150, 58 degrees. So this is 100, 110, 120, 130, 140, 150. And here again is the right hand rule. From this point you go 90 degrees, so you end up to the east-west line, and you count 85 degrees. So this is the second fracture or second joint, Okay, intersection is there. Let's see what we got. So that's the intersection is sigma 2, right? So it's exactly along the west-east line. So at the trend of sigma 2, all right, it's gonna be 270 slash 10, 20, 30, 40, 50, 60, 70, 80, 84, right? That's the trend and plunge of sigma 2. I need to draw the profile plane, so 90 degrees towards that direction. That's a plane of sigma 1, sigma 3. So here we have 6 degrees, so it's easy. I count the other way around, 6 degrees, and I trace the great circle. And then we need to count this angle, right? So if that one is less than 90, then the middle point is sigma 1, which looks like that. Let's see, 10, 20, 30, 40, 50, and 60 degrees, right? You count 30 degrees, so that's gonna be sigma 1, because sigma 1 is bisecting the acute angle. And then 90 degrees up from sigma 1 along the sigma 1, sigma 3 plane, that's going to be sigma 3, right? Here 30, 40, 50, 60, 70, 80, 90. So that's going to be sigma 3. So I have my ruler. So let's place this one through the center to sigma 3. That's the trend of sigma 3. And this one, it doesn't matter really. If you want to move your vellum paper, it's totally fine. Because we are making only sign. When you are reading, that is important to be fixed. Alright, so here is 10, 20, 29. So I'm gonna write 029 because this is two-digit number. Maybe somebody can be confused. Put the three-digit number for the trend, and the plunge is just 3 degrees, right? 0, 3, this is for sigma 3, and sigma 1 is 90, 100, 110, 120 slash 4 degrees. 0, 4 degrees, that's for sigma 1. Alright, we are done with this problem.